a couple of you did come and we discussed all kinds of stuff. But I want to see more of you to come. Because you can ask all kinds of homework questions during the office hour. That would be the best timing. Because we have so much things to cover, so many things to cover in every single lecture. If you noticed, I only give you one chance to practice in the very beginning of the semester, because we simply do not have that much time in class for you guys to practice and see whether you get it. So if you want to discuss with me individually, or you wanted to show me your work, whether it's going correctly or going incorrectly, come to my office hour, okay? And I have my office hour every Monday and Wednesday from 4:30 to 5:30. But I said this in several occasions. If you cannot make in these hours, you can always email me and say, hey, I want to come on Saturday afternoon. You want to spend a Saturday afternoon with me? Probably I would say no, but we can negotiate a different time, okay? Hopefully more people will turn out today. Well, I think you are going to the right direction. I will talk in more detail. Okay, so let's start our lecture today. So we're going to talk about triple integrals in this lecture. Okay, so there are two main goals. First is to get to know what triple integral is and how we evaluate the triple integral. And as we already have seen so many different times, the most difficult part is to identify the region. Okay, that's the first goal I wanted to achieve today. Second goal is to practice double integral. Okay, so the way to evaluate the triple integral in a lot of cases is to reduce it to a double integral. Okay, so this is section 14.4. Okay, and we're looking at D, where D is this integral region in R3, and F is the integrating function involving three independent variables. So in the very beginning, in get-go, I wanted to practice this triple integral, 0 to 5, 0 to minus x divided by 5 plus 1, 0 to minus x 5y 5. I want to integrate a function, constant function, dy. Just to show you how to compute a triple integral. So before I actually compute this triple integral, evaluate this triple integral, I want you to give me the identification of the intervening region. Z goes in the interior, so this is Z simple region, right? So this is Z simple region. Imagine if I eliminate the interior integral, I'll be able to eliminate the variable Z. And then the triple integral will be reduced to a double integral, right? So that's why triple integral and double integral are so tightly connected. So if you eliminate the middle integral, you're going to get a double integral in the outside. So double integral involving dx, dy, these two variables, which kind of region is it? It's a y simple region, right? So that's why I said in the very beginning of this lecture, it is not only to evaluate triple integral, but also to practice our double integral skills. So x is bounded by two numbers, 0 and 5. Y is bounded by two functions, a constant function here, and y equals minus x divided by 5 plus 1. All right? So if you eliminate the interior, you're getting a y simple region. Okay? So we should be very, very smooth about this double integral, x simple, y simple, polar, and x and r simple, all those things. So now I can begin my evaluation immediately. Even if you don't know the identification of the intervening, you can still do that, right? By eliminating these variables one after the other. So this is a constant function. The antiderivative function is z, just the z. And then I'm evaluating beginning from z is equal to 0, and z is equal to minus x plus 5 consistent with what I wrote on my notes. This is minus. So from 0 to minus 5, minus x minus 5y plus 5, and dy dx. Okay, so the interior region is 0 to 5, 0 to minus x divided by 5 plus y. What do we have? Minus x plus minus 5y plus 5 minus 0, basically, just dy dx. Okay, again, a small check right here. So from 3 integral signs to 2 integral signs, I eliminate one integral. Therefore, I have the integrating function contains no z at all. Okay, so you have to check there's no z here. So no z here, this is the only chance for you to end up with a number. If you still see z after you eliminate one variable or one integral, there's something wrong here. Okay, and then I can go further. One small remark I also want to make. After you eliminate one integral out of the 3, you're actually essentially dealing with a double integral, all right? Yeah. So in this step, beginning from this step, you can actually forget about your evaluating a triple integral. You can actually think about this problem as beginning from this stage, evaluating a double integral. You can apply all the skills we had before. You can transform from y simple to x simple. You can transform to a polar coordinate system. You can even transform it to a R simple region if it can be done. Okay? So you cannot restrict a skill in a triple integral. You already spent a lot of effort to acquire these double integral skills. You don't want to throw it away. So in triple integrals, you use this all the time. So here, because this is an all polynomial, it should be pretty easy to find the integral. So what is it? Minus half of, oh no, I'm regarding y as my variable, so it's not going to be the case. So it's minus xy minus half of y squared plus 5y, right? So please come together and we can work as a unit. So this is going to be evaluating from y equals 0 to y is equal to minus 5 of x plus 1, okay? So I got several emails asking me, oh, the evaluation in online homework questions is too complicated. And I agree with you. I agree with you, okay? Some of the evaluation is pretty complicated, but not in the conceptual level, right? So most of the times, it's just about a lot of polynomials you have to take care of. So let's work together and see if we can end up with the correct answer. So now I need to plug in y equals this and y equals 0. So y equals 0, this whole polynomial disappears, right? So I'm getting from 0 to 5. So minus x multiplied by minus x divided by 5 plus 1 minus half of x minus 5 divided by x divided by 5. I have to be extremely careful in every single step. Square, then minus plus 5 minus x divided by 5 plus 1 dx. Okay, so that's what we have. Okay, so these are all polynomials, so I'm not scared at all. So let's eliminate all the things. It's going to be minus 5x squared, so minus minus, so I got a plus right here. So minus x, so minus 5 over 2, so we have to expand the square. We're getting a 25x squared minus x2 divided by 5 plus 1, then minus x plus 5. Yes. Are we making any mistakes? I don't think so. So we can eliminate the middle big parentheses. So we're getting a 25, so it's going to be 10 x squared divided by 10. So I have a 5 divided by 2 and 2 divided by 5, so a plus x, and then minus 5 divided by 2 minus x plus 5, this whole thing dx. Okay? So always combine the like terms before you find the antiderivative. Don't find them individually. You're going to deal with much more terms. So we can combine the like term here. So I have, how many squares I have? I have a square here, I'm gonna get a x squared divided by 10, am I right? Yes? You guys just gave up or what happened? You're still working on that, right? So I'm combining the like terms here, so I have a second order term combined. First order term, I have a minus x, plus x, and minus x, so I have a minus x in total. And about numbers, I have a minus 5 divided by 2 and plus 5, so I have a plus 2 dx. Okay? So finally, if I eliminate the middle integral, I end up with one single integral where there's no y here. Okay, at least this is a good sign. Right? And then we can find the antiderivative function for this second order function. So it's going to be x cubed divided by 30, right? Minus x squared divided by 2 plus 5 divided by 2x. If I'm looking from x equals 0 to x equals 5, all right? Again, when x equals 0, the whole polynomial going to disappear. So when x equals 5, I end up with
125
divided by 30 minus 25 divided by 2 plus 25 divided by 2. So in the end, I end up with 25 divided by 6. All right? 25 divided by 6. So this is the answer. The main reason I'm completing the whole process here is to convince you, no matter how complicated it is, in a conceptual level, it is still a simple combination of single variable capitals, right? So you're just practicing your skill of how to find the antiderivative functions for polynomials. So in the end, you have to be very careful in every single step, because in the end, you're supposed to get a number, right? So this number can be easily changed if one of the steps in the previous is not correct. Okay? Any questions? No. Okay. So here is one thing I want to mention about online homework questions. So in the very beginning, I did mention to you to keep a workbook, all right? Because of the online homework questions, most of the times you're just putting a single number in the end, right? Sometimes if you put maybe 10,000 times and you still don't get a correct answer, you're frustrated, and I understand you. So if you have your workbook, you can bring your workbook for me, and I can check your work, and I can reimburse you the points. Okay? So keep your workbook and write it cleanly and clearly, not only for your own sake, but also it is much safer to avoid any mistake. Okay? So if you're writing your work messy everywhere, it is so easy to make mistake, and you're not going to end up with the correct number. Okay? So have your workbook and write everything cleanly and clearly. If you still cannot get the correct number in the end, bring your workbook with me so we can check it together, and I can reimburse you with the points you lose on the online homework questions. Are we good? Okay? So now I want to really identify this region. So this region is in fact the region bounded by the surface 5x plus 25y plus 5z is equal to 25 in the first octave. Okay? Have you heard about this word before? Okay. So in the two-dimensional place, if we have two axes, it's dividing the plane into 1, 2, 3 coordinates, right? So in the three-dimensional space, if you have xy plane, yz plane, and xz plane, these three planes will divide the whole space into 8 separate pieces, all right? So you can number them as the 8 octants. And the first octant, naturally, is going to be where x is positive, y is positive, and z is also positive. So this is our first octant. Okay? So this is indeed the interradial region where it is bounded by this plane and within the first object. So I can easily graph this plane, all right? How do we graph the surface? How do we graph the surface? Find the intercepts and find the traces. All right, so we can easily find all the intercepts. The x-intercept is 5, right? So you're getting rid of the x, y, z terms. And the y-intercept is 1, and z-intercept is 5. So I'm getting 5, 1, and 5. And because this is a plane, so all the traces are going to be all straight lines. So you can simply line together all these intercepts. So this is going to be the plane restricted in the first object. So my drawing skill is not the best, but for planing, we can do it pretty well. Right? So for plane, it's just a straight plane. And all the intercepts are 1 point, and all the traces are straight lines. Okay, so this is strictly speaking 5, 0, 0. So on y is going to be 0, 1, 0. And also this point is going to be 0, 0, 5. I can also derive all the equations for the traces. Right? We have done this before. So the xy trace is going to be letting z equal to 0. So I'm getting 5x plus 25y is equal to 25. So this is the equation for the trace lining on xy plane. All right? Mm-hmm. So the yz trace is given by 25y plus 5z is equal to 25. And xz trace is given by 5x plus 5z is equal to 25. Right? So this is indeed the integrating region we're doing the triple integral over there. And it is also a z simple region as we agreed in the very beginning. So generally speaking, if domain is a z simple region, it is written down as xy is coming from a region on the xy plane, and z is bounded by two functions of xy. Okay. Basically, xy is coming from a region on the xy plane, and z is bounded by a lower surface and upper